Alright, today's video is going to be on adding and subtracting fractions. So this page should be at the very back of your Exam 1 notes. So remember, when we are working with fractions, it is important anytime we add or subtract, we do have to have a common denominator. Okay, so the denominator basically gives us the size of the piece that we're looking at, and so in order to add and subtract, we need pieces that are the same size. A couple of things that are helpful: if you do have a whole number, if you want to write it as a fraction, you just put it over 1, and if you want to change a denominator, you can multiply by anything that is equivalent to the number 1. Remember, 1 is our multiplicative identity, so we'll talk a little bit about that as we get our common denominators. All right, so if we look at our first example, you'll notice that we already have a denominator of 6 on both of these. So anytime we're adding and subtracting fractions with the same denominator, we want to keep the denominator. That tells us the size of the piece that we're working with. And then we just subtract our numerators. So that gives me 2 over 6. Now if I want to write my fraction in lowest terms, also called reducing, I can look at what number will go into both 2 and 6, and that would be 2. So technically what we're doing here is we're dividing by 2 over 2. So we know that 2 over 2 is 1, and dividing by 1 doesn't change the value of the number. So 2 divided by 2 gives us 1, and 6 divided by 2 gives us 3. So 2 6 and 1/3 are the same fraction. They're equivalent, they have the same value, but this one is in lowest terms. Now most of the time we don't write this step out. Usually we do something like this, where we just say 2 goes into 2 one time, 2 goes into 6 3 times. And if you write it that way, that's fine also. All right, let's look at number 2. I'm going to do 4 plus 9 11ths. So I can take my whole number 4, and I'm just going to write it as 4 over 1. Okay, I'm going to leave a little space here, and I want to add that to 9 11ths. Now I do have to have the same denominator. So this one, I can make it into an 11 by multiplying by 11, but then I also have to multiply by 11 on top. So the idea here is that these numbers are what we call forms of 1. We know that 2 over 2 is equivalent to 1. We know that 11 over 11 is equivalent to 1. As long as we multiply by a form of 1, we change the appearance of the fraction, but we don't change the value. So that makes this first fraction into 44 over 11, and then we can add the 9 over 11. Now we have the same denominator. All right, so if we add the numerators, we get 53. We keep the denominator of 11. Now 11 doesn't go evenly into 53, so we can leave our answer here. You can change it to a mixed number if you want. You don't have to take that step. Don't start, cat. Sorry, my cat's over there making noise. All right, so we could say 11 goes into 53 4 times with a remainder of 9. So I could write that as 4 and 9 11. So anytime your numerator is bigger than your denominator, you can do that. But you don't have to take this step. Either one's fine. All right, so let's look at example 3. We have a denominator of 5 and a denominator of 7. So one way to get a common denominator is just to multiply those together. So 5 times 7 is 35. It will give you a common denominator. It won't always give you the lowest. In this case, 35 is our least common denominator because 5 and 7 don't share any factors other than 1. So to make this one into a 35, I need to multiply by 7. So I do that on the top also. To make this one into a 35, I need to multiply by 5. So I do that on the top also. So for each fraction, I multiply by something that is equivalent to 1. My first fraction becomes 28 over 35. My second fraction becomes 15 over 35. I can add 28 and 15. That's going to give me 43. 3 over 35. This is reduced. 43 and 35 don't share common factors other than 1. I'm not going to mess with changing it to a mixed number. I'm just going to leave it as 43 over 35. All right, so let's try number 4. We've got the whole number 2, so let's write that as 2 over 1. I'm leaving myself a little bit of space, minus 3/8 plus 2/3. So if I look at 8 and 3, if I multiply those together, I get 24. 24 times 1 is still 24. So 24 looks like a good common denominator. So to get 24 here, I'd have to go 1 times 24. So I do that top and bottom. To get 24 here, I would need to multiply by 3. So I multiply by 3 top and bottom. To get 24 here, I need to multiply by 8. So I do that top and bottom. So anytime you multiply something to a single fraction, it has to be equivalent to 1. So that gives me 48 over 24 minus 9 over 24 plus 16 over 24. So I'm going to keep that denominator of 24. I'm going to go 48 minus 9 plus 16. So 48 minus 9 would be 39. 39 plus 16 would be 55. So 55 over 24. I don't see any common factors top to bottom, so I'm going to stop there. All right, my last 2 examples, I'm going to have 3 denominators. So one way to get a common denominator is to multiply these together. So 3 times 5 times 2, that would give me 30. So I can use 30 for a common denominator. In this case, 3, 5, and 2, they don't share any factors except 1. So when I multiply them together, this does give me the lowest common denominator. So I'm going to write this, leaving myself some space. All right, so my goal is to make my denominator 30. That means 3 needs to be multiplied by 10. So here, 5 times 6 would give me 30, so I need to multiply by 6. 2 times 15 would give me 30, so 15 here. Again, all of these are equivalent to 1. So that changes my fraction into 20 over 30 plus 24 over 30 minus 15 over 30. So I keep that denominator. I'm going to go 20 plus 24 minus 15. That's going to be 44 minus 15. That's going to give me 29. So 29 over 30. That is reduced, and the numerator is smaller, so I can't change it to a mixed number even if I want to. All right, so the last one is the trickiest. If I try the trick of multiplying all these together, 6 times 3 times 8, you end up with a pretty big number. So we end up with 144. That will give you a common denominator, but it won't give you the smallest. So the problem is we share some factors here. 6 and 3 are both divisible by 3. 6 and 8 are both divisible by 2. So I want to see if I can come up with something smaller. So think about breaking these numbers down. 6 breaks down into 2 times 3. 3 is prime, so I'm just going to leave it as 3. 8 breaks down into 2 times 4, but 4 is 2 times 2. So if I look at it this way, I've got it all broken down. I definitely need 3 2's. But I don't need another one over here because this one has 1 2, so if I get these 3 2's, I've already got one for over there. So I want 3 2's. And then each of these have 1 3, so I'm going to try just 1 3. So I'm going to grab all of those numbers and multiply them together, and that's going to give me 24. So 6 times 4 would give me 24. 3 times 8 would give me 24, and 8 times 3 would give me 24. So it looks like 24 will be the best common denominator to use. All right, so I'm going to rewrite this with a little bit of space. My goal is to get a 24. So my first fraction, I need a 4 here, so 4 over 4. 3 times 8 is 24. So 8 over 8 here. Here I need a 3. So I'll multiply by 3 over 3. So I get 20 over 24 plus 16 over 24 plus 9 over 24. Okay, those are all positive. We add them all together. We get 45 over 24. Now our very first example reduced, and then we had a whole bunch that didn't. But if I look at 45 and 24, it looks like they're both divisible by 3. So I'm going to divide by 3 on the top and 3 on the bottom. That's going to give me 15 over 8, and that would be a reduced or simplified answer.